Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Moving on, we have our protocol suites. These are the groups of protocols, and this is a group of identified interrelated protocols necessary for communication. Protocols can work by themselves or as groups. Protocols are viewed in terms of their layer. Are we talking higher layer or lower layer? And that kind of depends on what their functionality is doing. Here we have the same breakdown that we had earlier. We have the application, which is a higher layer. We had our transport, which was, again, how it went through the network and it managed our sessions. We had internet, which was how it connected to the destination. And then we had our network access. So again, we used Ethernet, we used IP, TCP, and HTTP. This right here is known as a reference model. This happens to be the TCP/IP reference model, and communication is broken down into 4 layers. However, TCP/IP reference model is one of 2 major types of reference models. The OSI is the Open System Interconnection model, and that is the second major type. Within any Cisco course, you will learn about the OSI reference model because that's how we relate everything back to it. In following videos, we're going to be talking about data communication as it refers to the OSI reference model. They start off with TCP because it's a little bit simpler. Again, TCP/IP will operate at the application, transport, and internet layers, and it will use the most common network access for connectivity. The network access will be whatever our network is running, and almost all networks will run Ethernet. Ethernet is our layer 2 technology, and that's actually how we put data on our network. So the TCP/IP protocol suite is made up of several protocols. How we define our application protocols, they break them down into like name systems, host, email, and so forth. Here is the different groups for the transport layer, and again the protocols that operate them, and at the internet layer. And again, they break them down into internet protocols, messaging, and routing protocols. Here's the overall structure of how we deal with the different protocols at each of the layers of the TCP/IP model. So at this level, you don't really need to know each of the protocols, but it starts helping to start looking at the common protocols, because there are so many protocols to learn, and we're going to be breaking them down as we discuss each of the layers. So within our communication, each layer actually will engulf the layer above it. So that's called our encapsulation. Here we have a data. This will be HTTP. It will be engulfed with TCP. TCP will completely surround it. IP will completely surround the TCP and data unit, and then Ethernet will completely surround it. From there, and that Ethernet group will be broken into bits, and it'll be sent to the destination, and they will de-encapsulate it. They'll break it down, they'll ungroup it from Ethernet to IP to TCP back to data. So that is how the encapsulation packet, or the encapsulation process works in a nutshell. We're going to break it down a little bit simpler by the end of this video, but for now, that's kind of the functionality. Let's talk about standards organizations. We have lots of standards, and each standards are managed by a group. These groups are typically nonprofits, and they are classified as open standards. The standards allow for interoperability, competition, and innovation. And they should be vendor neutral, nonprofits, and they help to establish and develop these standards. things like IEEE, IANA, INTF, Tierra, ITU, or ICANN. Each of these groups provide vendor-neutral structure to communication. For example, we have the Internet Society, ISOC. From there, we have the Internet Architect Board, IAB. IAB actually breaks down certain things into different groups. We have an Internet Engineering Task Force. We have an Internet Research Task Force. And again, they're separate. They do specific things. The Internet Engineering Task Force will help develop, update, and maintain Internet and TCP/IP protocols, where the Internet Research Task Force focuses more on long-term research related to the Internet and TCP. So again, they structure this in such a way so that we have certain groups that govern how we function, how the Internet functions, how TCP/IP functions, and so forth. We have basic Internet standards. We have ICANN. This coordinates IP address allocation and the management of domain names and assignment to other information. Then we have the Internet Assigned Number Authority, IANA, and they oversee them and manage IP address allocations and domain name management and protocol identified for ICANN. So ICANN manages it, but ICANN's too big, so ICANN kind of forms out some of the requirements and the management to IANA. That just shows us the structure of what they're doing. So things like domain names, addresses, things like that, IANA and ICANN are in charge of. So moving on, we have a few other electronic and communication standards like IEEE, IA, and TIA. They make up a lot of our physical media standards. We have an International Telecom Union, ITU, and those focus on video compression, IPTV, broadband communication, and DSL. IA-TIA also outline our physical wire layout, our pinout for our cabling. We have a lab. So let's go ahead and let's dive into our reference model. Again, our reference model is how we tie back communication flow conceptually to the actual communication flow. We have two major models that we need to know about, TCP/IP and OSI. OSI has 7 layers: application, presentation, session, transport, network, data link, and physical. And they correspond to the TCP/IP models: application, transport, internet, and network access. So you can compare and contrast the two models. You'll see that for OSI, the top 7, 6, and 5 layers line up with TCP's 4th layer. These 3 are this single layer. They have matching transport, and they have matching network or internet layers. And then the network access is the data link and physical layers lining up. So the nice thing with these reference models is within later lessons, we actually have a detailed breakdown of each of these layers because we reference almost everything back to these layers. So the middle portion is about being able to understand what protocols operate at those layers. So we know if we're talking HTTP, we know that's going to be in the application, presentation, and session layer groups. If we're talking TCP or UDP, we know that's going to be the transport layer for the OSI or the TCP/IP model. If we are talking IP or ICMP, it will be the OSI network or the TCP internet layer. If we're talking Ethernet, we know it is either data link physical or the network access, kind of depending on if OSI or TCP. But everything we go back to will reference this model. OSI is going to be one of the more important ones because within the Cisco material, that is one that is covered the most. The benefits of using a layered model is it assists in protocol design because the protocols that operate at a specific layer have defined information to act upon. It fosters completion because products from different vendors can work together. It does prevent technology or capability changes in one layer from affecting things in another layer. Lastly, it does provide a common language to describe networking functions and capability. This is one slide that I recommend most people hand write out. Understand the layer numbers, understand the layer names, and understand the general description at each layer. You need to know that the application layer contains protocols used for processing to process communication, host to host. This is also where the user interacts with the application. Presentation is where we represent data to the application. This also includes data transfer to an application layer services. Session provides services for the presentation layer and to manage data exchange. Transport will define services for segment, transfer, and reassemble of individual communication links. The network layer provides services to exchange individual pieces of data over a network. Data link will describe the method for exchanging data frames over a common media, and physical describes the mean to activate, maintain, and deactivate physical connections for digital communication. Don't worry, we actually have later lessons coming up that will break this down even further. We have our TCP/IP reference model, and again how they correlate, because we need to understand the comparison. Layers 7, 6, and 5 correlate to the application layer for TCP. Layer 4 correlates to the transport layer. Layer 3 correlates to the internet layer. And layers 2 and 1 correlate to the network access layer. We have a packet tracer lab kind of helping to explore this type of traffic. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.